Picture yourself in a dark room, your face illuminated only by the cool glow of a screen, showing galaxies slowly spinning in deep space. You watch those swirling arms of starlight and feel unmistakably small. You assume, as we all have been taught, that you are merely a fleeting guest in a vast, objective reality. You believe that out there in the icy vacuum, a colossal cosmic machine continues to turn its ancient gears whether you witness it or not. For centuries, this has been the bedrock of our scientific understanding. We are taught that reality is a cold, indifferent machine, a grand stage composed of dead rock and empty void that exists independently of us. But what if the universe isn't so rigid? What if its breathtaking vastness is inextricably connected to your perception? What if your conscious act of observation is the invisible force that brings the cosmos into solid being? We are the unknown. Tonight, we explore a concept that threatens to shatter the foundation of everything you think you know about the physical world. We push past the reassuring illusion of solid objects into a probability-driven place where the ordinary rules dissolve, chasing a principle that sounds less like physics than like magic. Consciousness itself might be the true source code of reality. The most fundamental law of nature might simply be this: the universe's code only runs when you choose to observe it. Let those words settle quietly into your mind. Let them echo in the dark room around you. The code only runs when you observe it. To understand the magnitude of this concept, we cannot start with complex mathematics. We must begin with something deeply human, the quiet assumptions we make every day without realizing it. There is a cognitive milestone we all pass, known simply as object permanence. It is one of the first concepts we grasp as infants, the building block upon which our entire adult understanding of reality is constructed. Imagine being only a few months old, experiencing the world as a chaotic mosaic of light and color. When a parent hides a brightly colored toy behind their back, to your developing mind, the toy hasn't merely been obscured. It has vanished from existence. The universe has swallowed it whole. But soon, through endless repetition, you learn the trick. You learn that the toy is still there, waiting patiently just out of sight. You internalize the unshakable belief that the physical world possesses an objective permanence, that the things around you do not dissolve into mist just because you turn your head away. As you grow, this assumption hardens. It becomes the unquestioned bedrock of your daily reality. You assume with certainty that your house is still standing exactly where you left it when you drive away for work in the morning. You trust that its wood, brick, and glass will obediently hold their molecular structure until you return. You assume the distant mountains remain towering on the horizon even when shrouded in morning fog. You assume that when you park your car and walk away, it remains a heavy block of metal resting on the concrete. Think of the familiar experience of listening to a car radio. Imagine you are driving alone late at night, the highway dark and empty ahead of your headlights. The cabin is filled with the warm sound of a late-night broadcast. You pull into your driveway, turn the key, and the engine dies. The music stops mid-note, replaced by its sudden silence. You step out into the cool night air and close the door behind you. As you walk toward the glowing windows of your house, you carry an absolute certainty that the radio station is still broadcasting out there in the dark. You believe that the invisible electromagnetic waves carrying that music are still passing through the silent cabin of your parked car. You know that if you were to turn around, sit back in the driver's seat, and turn the key once more, the music would resume, indifferent to your temporary absence. We believe with every fiber of our being that the world persists. We believe it exists in a hard, definite state, whether we are there to witness it or not. We believe the universe is a self-sustaining entity, a clockwork mechanism that goes about its cold, mathematical business in the dark, indifferent to our presence. It is a comforting thought. It relieves us of the burden of maintaining reality. It allows us to sleep, trusting that the floor will still be there when we swing our legs out of bed in the morning. But let us suspend our disbelief for a moment. Consider this deeply ingrained assumption with fresh eyes. We must strip away everything you have been taught since childhood, peeling back the layers of common sense. We must strip away the comfort of everyday certainty and ask a question that borders on the terrifying. How do you actually know that the physical world persists exactly as it is when you look away? How can you be certain that the universe does not alter its behavior the moment your conscious attention is removed from it? The truth is astonishingly simple and deeply unsettling. Despite all our centuries of science, despite our towering observatories and massive particle accelerators, we have never actually proven that the universe exists in a definite state when we look away from it. It sounds absurd at first, like a cheap philosophical parlor trick designed to confuse. Common sense rebels against the idea. Of course, the world exists when we aren't looking. If you leave a glass of water resting on your nightstand, close your eyes tightly for 10 seconds, and open them again, the glass is still sitting there, exactly as you left it. If you set up a recording camera in an empty, locked room and return hours later to review the footage, the screen shows that the room remained solid, static, and unchanged while you were away. You can watch the recorded shadows crawl across the dusty floorboards, seemingly proving beyond any reasonable doubt that the physical space was right there, existing objectively, without your eyes present to witness it. But think carefully about what you are actually doing in those moments of verification. When you open your eyes to check on the glass of water, what are you doing? You are observing it. When you sit down at a monitor and hit play to watch the remote camera footage, what are you doing? You are observing the recorded data, bringing the information into your conscious awareness. You are always, inevitably, catching the universe in the act of being observed. You are never catching it in the act of being unobserved. You cannot, by definition, observe a universe that is not being observed. It is a logical impossibility, a paradox from which there is no escape. Every time you try to verify that the external world is still there, you must bring your conscious attention to it. You must measure it, look at it, or listen to it. And in doing so, you introduce the act of observation into the system. You may, in fact, be the mechanism that is forcing the chaotic potential of the universe to take a definite shape. Imagine you are a person walking through an unfamiliar, pitch-black house at midnight, armed only with a flashlight. You are trying to see what the darkness actually looks like. But wherever you point the beam, there is only blinding light. The darkness vanishes the instant you try to look at it. The walls leap into existence. The furniture casts sharp shadows. The dust motes dance in the beam. Wherever you point your attention, wherever your light falls, there is a solid, measurable reality. But you can never see what is truly happening in the undisturbed shadows resting quietly behind you. The act of looking destroys the unobserved state you are trying to witness. Therefore, the uncomfortable truth remains. We have never proven the universe exists in a solid, physical state when we look away. We have also never proven that it disappears. Those two statements are not the same thing, and the gap between them is where the greatest mysteries of modern science now reside. This is a crucial distinction to hold in your mind. We are not saying that when you close your eyes, the physical world suddenly vanishes into a void of nothingness. We are not suggesting that reality is a flimsy illusion that flickers out of existence the moment you turn your back. What we are exploring tonight is something far stranger and far deeper. We are saying that the true, underlying state of the universe when it is isolated and unobserved is fundamentally unknowable to us, and perhaps, at its most basic microscopic level, it is simply undefined. It does not have a set state until it is forced to choose one. To grasp this, think of an open-world video game. The engine never renders the whole digital world at once. It generates only what falls within your character's field of view, leaving the distant mountains and the towns you haven't visited as unmanifested potential. Silent lines of code waiting on a hard drive until your avatar crests the hill and looks. The code only runs when you look. We must ask ourselves a staggering question. Could our own physical universe be operating on a similar principle? Could the seemingly permanent objects surrounding you at this moment, the chair beneath you, the painted walls of your room, the burning stars in the night sky, be akin to that dynamically rendered digital scenery? When these objects are being observed, touched, or measured, they are definite, dense, and real. They have mass, location, and velocity. But what happens when you look away? What happens when you leave the room and close the door, or when you fall asleep and your conscious awareness slips away into the dark? Do those objects revert to a state of pure mathematical potential? Does the matter that makes up your life dissolve back into the invisible code of reality, becoming nothing more than overlapping waves of probability, untethered from any fixed form? This single thought has the power to change how you experience the quiet, dark room around you right now. When the glowing screen fades to black and you are left in the silence, you no longer need to feel alone in a dead, mechanical void. Instead, if you listen closely, you can almost feel the electric hum of pure potential. The darkness pressing in around you is no longer just an absence of light or an absence of matter. It is a shimmering canvas of infinite possibility. It is a state of raw, unformed existence, waiting for your conscious attention to strike it and paint the physical world back into being. Every time you open your eyes in the morning, every time you reach out a hand to touch a textured surface, every time you bring your awareness to the present moment, you are doing something miraculous. You are participating in the creation of reality. You are collapsing invisible waves of probability into the specific, concrete experience of your daily life. The world, in this view, does not merely happen to you. You are not a passive observer trapped in a rigid machine. The world happens with you. You are a fundamental ingredient in the recipe of existence. There is a profound, almost intoxicating peace to be found in this thought, especially as you prepare to drift into sleep tonight. When you close your eyes and let go of your waking consciousness, releasing your grip on the day, you do not need to worry about maintaining the rigid architecture of the physical world. You can simply exhale, letting the solid, exhausting structures of your day dissolve back into the formless, quiet sea of potential from which they came. The universe, in its efficiency, will hold itself in a state of mathematical suspension, hovering in the dark, waiting for your return. And when you wake to the soft morning light and your awareness rushes back into your body, the cosmic code will run once more. The world will bloom back into solid existence, rendered perfectly just for your observation. But as explorers of the unknown, we cannot stop at poetry. We must ask the difficult, empirical questions. Is this concept merely a philosophical comfort? Is it just a poetic thought experiment designed to soothe the existential dread of the human mind? Or could there be rigorous, quantifiable evidence that the physical universe truly behaves this way when we aren't looking? We have built the entirety of human civilization, our cities, our technologies, and our daily routines, on the practical belief in objective permanence. We have bet our lives on the idea that the world is solid. But the relentless process of scientific observation has a long history of gently, methodically dismantling our most cherished assumptions. A little over a century ago, when physicists first began to develop the technology to peer into the microscopic foundations of reality, they expected to find the ultimate building blocks of the machine. They expected to find tiny, predictable objects behaving like miniature billiard balls bouncing around on a green felt table. Instead, what they uncovered shocked them to their core. They found a realm that defies every tenet of human common sense. They discovered a shifting, unpredictable space where the old rules of classical physics violently break down. Down in the quantum depths, we can no longer prove that fundamental particles exist in definite locations when we aren't watching them. And even more staggeringly, we can no longer rule out the possibility that the very act of our looking is what calls those particles into being. This strange, shape-shifting behavior isn't a fringe theory discussed in dark corners. It is a fundamental, experimentally verified property of nature that we can observe, measure, and replicate in a laboratory. It is the engine that powers the sun and the technology in the device you are using right now. To see how this probability-driven reality works, to see the curtain of everyday illusion pulled back to reveal the hidden mechanics of existence, we do not need to rely on imagination alone. We can turn to the most famous, mind-bending experiment in the history of physics and watch exactly what happens when a single beam of light passes through the quiet, dark, settle into the quiet of a darkened room. We step away from the cosmic void and come down to Earth into a space of focused stillness. Heavy velvet curtains are drawn tight, sealing the room in a cathedral-like silence, isolated from the city's hustle. The air carries the scent of old paper, leather bindings, and the faint tang of scientific instruments. The outside world is shut out so the subtle whispers of nature can be heard. The year is 1801. Outside, London is a chaotic city choked by coal smoke and the roar of the early Industrial Revolution. Yet in here, time settles into a quiet vigil. It is an era poised on the precipice of technological transformation, yet intellectually still tethered to the giants of classical physics from the past century. The deeper mysteries of nature remain hidden, waiting for a patient mind to uncover them. In this darkened room stands Thomas Young, a polymath whose intellect effortlessly spans linguistics, music, and anatomy. He is now surrounded by towering stacks of annotated journals, polished lenses, and meticulous diagrams. He is thinking deeply about the fundamental nature of light. For decades, the prevailing belief was that light consisted of tiny, solid corpuscles, treated by the scientific establishment as gospel. To question this was scientific heresy. Classical theory dictated that light was made of indestructible particles, traveling in straight lines like an infinite spray of microscopic sand. This intuitive view aligned perfectly with a clockwork universe. Every sharp shadow and keyhole beam seemed to confirm everyday logic. Particles travel in straight lines and are blocked by solid objects. But Thomas Young, observing the glowing halos around a candle flame on a foggy night, and the iridescent colors shifting on the thin surface of a soap bubble, senses a more elusive truth. He notices how light seems to bend ever so slightly around the sharp edges of thin obstacles, a subtle phenomenon called diffraction, which rigid particles shouldn't do. A bullet does not bend around a corner. He realizes light is not a barrage of rigid bullets, but something far more fluid and interconnected, something that ripples. Defying the overwhelming consensus of his peers, he proposes that light actually behaves as a wave, a radical proposition threatening to upend a century of entrenched physics. To test this intuition, he devises an experiment of breathtaking simplicity. In his darkened room, he allows a narrow shaft of sunlight to enter through a tiny pinhole in the window coverings. In the path of this beam, he places an opaque screen into which he has cut two parallel slits. Beyond this barrier, he places a blank canvas to catch the light passing through the twin gaps. If the classical view was right, and light was a stream of tiny particles, passing them through two slits should create exactly two bright lines on the screen behind them, just like spraying paint through a stencil. The solid barrier would stop most particles, while the gaps would allow two distinct streams to pass unimpeded. The particles would travel straight through, landing in two separate bands. There should be no mystery. But that is not what Thomas Young sees. Leaning closer in the dimness, he does not see two isolated bands of light. Instead, he sees a rhythmic pattern, a series of alternating bright and dark stripes spreading across the surface. This is an interference pattern. Imagine a glassy pond on a perfectly still day. If you drop two small pebbles into the water nearby simultaneously, each creates circular ripples expanding outward across the surface. As these concentric circles grow and inevitably intersect, they interact with one another. Where two rising peaks of water meet, the water rises even higher, amplifying the crest. But where a rising peak meets a falling trough, they cancel each other out, leaving the surface of the water perfectly flat and still. The overlapping ripples create a stationary pattern of high peaks and flat spots. This phenomenon is known as wave interference, and this is exactly what Young is seeing with the sunlight. The single beam hits the two slits and splits into two separate waves. These new waves wash over each other as they travel to the screen, combining to create bright stripes where they amplify and dark stripes where they cancel out. It is an undeniable demonstration. Light is a wave. The elegant experiment eventually shattered prevailing dogma. For a long time, science rested comfortably with this explanation. The universe seemed orderly, operating on sensible, continuous rules. But the universe is not simply mechanical clockwork or continuous fluids. It is far more mysterious and sensitive to our presence. As the 19th century yielded to the 20th, our tools became sharper. Our vision pierced through the macroscopic illusions of everyday life, allowing us to peer deeper into the fabric of reality, down to individual atoms and the subatomic particles that comprise matter and energy. Scientists eventually returned to Young's elegant experiment, this time with modern technology. Instead of a continuous beam, they fired solitary particles, one electron or photon at a time. It was the ultimate reduction of the experiment, looking at individual behavior. They fired these lonely travelers toward the barrier. Beyond the slits, sensitive detectors caught the impact of each particle, leaving a tiny dot on the dark screen. There is no ambiguity here. A single particle is a localized point, not a smeared-out wave. The first particle is fired, passes the slits, and lands on the screen as a discrete dot, like a tiny bullet. The next particle is fired, landing elsewhere. Particle by particle, they are fired one by one, with plenty of time between them to ensure they cannot interact in flight. There is no continuous wave here, only isolated events. You might reasonably expect these tiny bullets to simply pile up behind the two slits, building two blurry lines. After all, a marble dropped through a slot lands directly below. But as thousands of single dots accumulate over hours, something impossible emerges. The scattered dots do not form two distinct lines. Slowly, they arrange themselves into a pattern. Point by point, they build the exact same interference pattern Thomas Young saw. The alternating bands of high and zero impact, the unmistakable signature of a wave. This result is profoundly unsettling. How can isolated particles, fired one at a time, know where to land to form a collective wave pattern? Traveling alone, a particle has no other ripples to interact with. The mathematics of quantum mechanics offer a strange explanation, forcing us to abandon our everyday intuition. The equations tell us the single particle is not traveling as a solid object with a defined trajectory. Instead, it travels as a wave of probability. It moves through both slits simultaneously, existing as a sprawling smear of mathematical potential. The particle's possible locations wave and ripple through empty space, actually interfering with themselves, right up until the microsecond they strike the plate. Only upon physical impact with the detector screen does the wave of probability suddenly collapse into a definite point of physical reality. The particle exists in a ghostly state of superposition, exploring everywhere at once, until it hits the screen and is forced to choose a concrete location. This behavior is strange enough to keep a physicist awake at night. But the story does not end here. The experiment takes a twist that challenges everything we know about the nature of existence itself. Troubled by this bizarre behavior, scientists decide they need to know more. They modify the experiment, placing an unobtrusive detector right at the slits. Its only job is to silently observe and record exactly which slit each particle passes through. They change nothing else. The emitter and the photographic plates remain identical. The only difference is that now, the particles are being watched. Information about their chosen path is being recorded. They begin again. The first particle is fired. The detector notes which slit it passes through. A dot appears on the screen. The next particle is fired and observed. Particle by particle, they slowly build the image. But as the pattern emerges, the researchers are met with a profound shock. The interference pattern is gone. Completely gone. In its place are only two distinct bands of dots. The exact pattern expected from tiny bullets fired through two holes. Because the detector watched them, the particles simply stopped behaving like probability waves. They abandoned their omnipresent rippling and acted exactly like solid physical objects moving in straight lines. The wave function didn't just collapse at the screen. It collapsed the moment it was observed at the slits. Let that sink in. The fundamental nature of the physical universe, whether it behaves as a wave of possibilities or a localized object, changes simply because it is being looked at. Matter alters its behavior based on whether we extract information about it. The act of observation is not passive. It is an active, creative force reaching into the mechanics of reality. When unobserved, the universe exists as a shimmering haze of probability spread across space and time. But the moment we turn our gaze upon it and demand to know its state, that haze snaps into sharp reality. It is as if the universe is waiting for us to define it. Consciousness is no longer just a passive audience watching the movie of reality. It is intimately entwined with the functioning of the cosmos, acting as a kind of cosmic compiler. In computer science, a compiler translates abstract code into executable reality. Similarly, observation and consciousness seem to compile the abstract mathematics of quantum probability into the solid physical world we measure. Until that compilation happens, the physical world does not truly exist in a definite state. It remains a sprawling set of equations waiting to be rendered. This is the profound melody playing at the very bottom of reality. The code only runs when you look. This brings us to a mesmerizing precipice. It forces questions rooted in replicated scientific observation. If the universe behaves as a hazy cloud of probabilities when unobserved and only solidifies when measured, an undeniable structural similarity emerges. This on-demand rendering at the microscopic quantum level mirrors exactly how a modern video game engine operates. To save precious computational power and memory, a massive open-world game doesn't calculate the entire digital universe all at once. It only renders the specific scene, the exact polygons and textures that the player's camera is actively looking at. The rest of the digital world remains unexecuted code, waiting in the background as raw potential. The fundamental mechanics of our physical universe appear similarly optimized, efficiently rendering the physical world out of a cloud of probability only when an observer or a measurement demands a concrete outcome. This inescapable logic leads to an astonishing thought. If the universe's architecture functions like an advanced rendering engine, conserving resources until measurement demands a physical outcome, Then what exactly is this vast universe we move through every day? Are the burning stars, rocky planets, and rippling light merely the real-time output of a cosmic computation? As you rest in the quiet dark, consider the profound implications of those collapsing probability waves. The question lingers not as science fiction, but as a mathematically grounded interpretation of modern physics. Are we living inside a computer? As we continue to drift, letting the accumulated weight of the day settle into the quiet earth, we return to the steady rhythm of our breath. It is a slow, reliable tide, a soothing metronome keeping time in the silence of the night. You are safe here. You are resting, enveloped in the soft folds of your heavy blankets. You are present in this quiet moment, allowing your tired mind to wander, untethered from any need to solve, to fix, or to plan. We are just exploring now, drifting like a solitary ship on a calm, dark ocean, charting the scattered stars of our inner understanding, with nowhere else to be and nothing else to do. In our modern era, as technology has grown more complex and seamlessly woven into our everyday routines, a new story has emerged. It is a story told by technologists, debated by academic philosophers, and whispered by the architects of our digital world. It is the disorienting idea that our reality, the physical universe we assume to be solid and permanent, might actually be a simulation. It is a compelling thought that echoes through our culture, animates our science fiction, and fuels our midnight conversations. They suggest, with increasing mathematical seriousness, that the detailed world around us, the burning stars above, the solid ground beneath our feet, might simply be the product of an unseen computational process. But when we try to picture this cosmic simulation, we project our own limitations onto the limitless canvas of the cosmos. We imagine the universe as a scaled-up reflection of our own human creations. When the modern mind hears the word simulation, it conjures images of the metallic technology we already know so well. We picture a giant, humming server farm, hidden somewhere out in the cold beyond. Let us take a moment to explore that image, to step inside it, and understand what it feels like to stand in the presence of such a machine, and then, having seen it, to let it go. Imagine the kind of earthbound server farm that houses the flowing data of our interconnected world today. It is a sprawling industrial complex, often located in the cool, remote climates of the far north, nestled near icy rivers or frozen tundras, just to keep the machines from overheating. Inside its windowless, fortress-like walls are rows of towering metal racks, stretching out in dimly lit aisles that vanish into an artificial forever. The sterile, conditioned air is filled with the monotonous roar of tens of thousands of spinning cooling fans, a mechanical wind trying to dissipate the heat generated by all that trapped processing power. Tiny blinking lights, emerald green, icy blue, and warning amber, flicker across the dark faces of countless humming servers, creating an artificial constellation of data moving in the gloom. It is an environment of brutal efficiency. It is a place built of spun copper wiring, bundles of glass fiber optic cables, steel framing, and poured concrete floors. This is our best current version of computing. It is a physical, heavy, energy-intensive process. It requires vast amounts of electricity to function for even a single second, pulling power from interconnected grids that span entire continents. It requires an array of physical materials mined from deep within the earth, rare metals extracted with great effort, refined plastics shaped in industrial molds, and tempered glass. Understandably, when some people try to imagine the universe as a simulation, they imagine a scaled-up version of this specific human creation. They imagine a machine of staggering size and complexity, a cosmic server farm whirring in some distant, higher dimension, crunching the numbers that render our swirling galaxies, our orbiting planets, and our fragile daily lives. They might even imagine a team of advanced beings walking the cold aisles of eternity, maintaining this hardware, checking the cooling systems of the cosmos, replacing burnt-out celestial circuits, and keeping the power grid of reality online. Take a moment to imagine the absurd scale required for such a thing to exist. If we attempted to build a computer powerful enough to simulate even a tiny fraction of our blue planet, the energy requirements would be astronomical. We would need to harness the power of multiple burning suns just to run the calculations required for a single rolling ocean, mapping the trajectory of every falling drop of water, every shifting thermal current, and every drifting microscopic organism. Now, imagine scaling up that requirement to encompass a solar system, a spiral galaxy, and finally an expanding universe containing hundreds of billions of galaxies. The physical infrastructure required to construct such a machine defies mathematical logic. A machine of that mass would collapse upon itself under the weight of its own gravity, forming a black hole of computational hubris. It would consume all the available matter and free energy in the base universe it was meant to reside within, just to turn itself on for a single second. This is the fatal paradox of the physical simulation theory. It requires far too much material, energy, and space to ever be a reality. It is a clumsy, brute force approach to explaining the miracle of our existence. But when we consider the intricate balance of the natural world around us, we realize that nature is never clumsy. Nature does not waste effort or space. Nature is breathtakingly elegant. Nature is efficient in everything it does. The popular version of simulation theory begins to unravel when we recognize our ingrained habit of anthropomorphizing the universe. It is a human tendency to assume that the nature of reality operates exactly like the tools we happen to be inventing in this fleeting century. Just a few hundred years ago, when the pinnacle of technology was the mechanical clock, people imagined the universe as an intricate clockwork mechanism, with the divine watchmaker winding the cosmic springs and setting the interlocking brass gears in perpetual motion. Later, during the soot-stained steam age, the same universe was envisioned as a thermodynamic engine, full of pressure and heat. Today, living in the age of digital information, we look up to consider the cosmos, and we almost lazily imagine a giant, glowing computer. But let us pull our focus back and think closer to home about the actual tools we use to compute on a daily basis. Think about the familiar devices that surround us in our quiet homes and busy offices. Consider the stiff plastic of the credit cards resting in your wallet. Embedded in the surface is a gleaming metallic square, a microchip. That small chip is a marvel of human engineering. It contains millions of microscopic pathways holding your encrypted information, and it is capable of communicating with complex global networks in a fraction of a second. Or think of the smooth glass surface of the smartphone resting on your nightstand, or the metallic shell of the laptop sitting silently on your desk. At the heart of all these devices are brittle silicon chips. Silicon is not some rare, magical substance beamed down from the heavens. It is a common material found in ordinary dirt and rock. It must be gathered from the ground, heated and refined, purified, sliced into impossibly thin wafers, and etched with microscopic geometric patterns using focused beams of light. Take a moment to consider the gritty reality of how these chips come to be. Beneath the seamless magic of the digital screen, there is the harsh reality of physical manufacturing. There are factories covering acres of land and noisy assembly lines stretching for miles. There are the mining of rare earth elements, the smelting of raw metals, and the controlled layering of toxic chemical solvents. Every microchip we casually use requires a coordinated global infrastructure of extraction and creation just to exist. The computer chip, for all its astonishing processing power, is still a physical object. It remains bound by the unforgiving laws of thermodynamics. As it works, it generates waste heat that must be cleared away. It degrades and wears out over the passage of time. It can be snapped, crushed, or broken. It has a measurable weight in the palm of your hand. It takes up a specific amount of space in the world. It is constructed of spinning atoms, bonded molecules, and solid matter. It is, quite simply, made of stuff. And right here is the logical flaw in the captivating idea of a giant, physical cosmic computer rendering our reality. It requires physical stuff in order to make the physical stuff we see around us. If our complex universe is a digital simulation running on some hidden machine, then we must stop and ask, what, exactly, is that machine made of? If our reality is being rendered by processors and motherboards located in a higher base universe, then that higher universe must also be made of tangible materials. It must possess its own physical laws, its own fundamental elements, and its own parallel version of mined silicon, copper wires, and flowing electricity. If that is the case, we haven't solved the mystery of existence at all. We have simply moved it one frustrating step further away from ourselves. We have pushed the question of origin up one inaccessible level of reality. If our universe is a simulation running on a giant computer sitting in some base universe, we still have to ask the same difficult questions. Where did that base universe come from? How did it begin? Where did the materials needed to build that reality-generating computer come from? The idea of a giant physical machine rendering our world is too clunky, too heavy, and too bound by the rules of the very reality it is supposed to be creating. Fundamental reality, the bedrock of all existence, cannot be made of the same degrading matter that we find within our own world. The architect of the universe cannot be built from the same crumbling bricks used to construct the finished building. So, as you lie here now, safe and comfortable under your covers, let the image of that cosmic server farm fade away into the velvety dark behind your closed eyes. Let the blinking of those green and amber lights dim, soften, and disappear from your mind. Let the roar of those thousands of cooling fans wind down, softening into a deep and peaceful silence. Feel the endless racks of steel servers dissolve into a cool mist, drifting away on a night breeze, leaving behind only the unburdened space of your own quiet awareness. The universe is not a clanking machine. It is not a wound clockwork toy full of brass gears. It is not a steam engine venting hot gas. And it is certainly not a humming supercomputer made of glowing metal, rigid plastic, and fragile glass. It is something more elegant, more profound, and perhaps, at its core, simpler. It does not require continents-wide grids of electricity to sustain its existence. It does not need fans to cool the heat of its universal calculations. It is not constrained by the limits of copper wiring or the material properties of mined silicon. If the universe is indeed computing itself, weaving the fabric of reality moment by moment, it is doing so without any physical hardware whatsoever. It is a computation that does not require a solid substrate in any way that we can currently build. It is an ongoing process that operates at a level far deeper, far older, and far more basic than physical matter, deeper even than the invisible flow of energy. Think for a quiet moment about the nature of a single thought. When you have a thought right now, lying in the dark, where does that thought exist in physical space? What exactly is it made of? We know that neurons are firing in the physical brain, sparking electrical impulses across microscopic synapses. But the internal experience of the thought itself, the warm memory of a loved one's face, the remembered feeling of summer sun on your skin, the click of understanding a complex idea, that inner experience is not made of stuff. You cannot hold a memory in the palm of your hand. It is a flowing pattern. It is a relationship of invisible connections. It is a weightless form of living information. Perhaps, in its deepest nature, the universe is more like a passing thought than a grinding machine. Perhaps the physical world around us, with its gray stones, flowing rivers, and burning stars, is not the foundational hardware of reality at all, but rather the rendered software. Or perhaps the human distinction we make between hardware and software dissolves entirely when we reach the most fundamental levels of existence. We humans are used to the intuitive idea that you always need a physical object to hold and store information. We believe we need a paper book to hold printed words, a vinyl record to hold captured music, a spinning hard drive to hold a digital photograph. We assume, based on the limited evidence of our daily lives, that information is somehow secondary, a passenger hitching a ride on the heavier, supposedly permanent vehicle of matter. But what if we have it backward? What if weightless information is the original substance of all reality, and what we call physical matter is just the temporary way that information happens to be organized and presented to our senses? What if the heavy stuff of the universe is not the foundation of everything as we assumed, but simply the fleeting result of a deeper informational process? When physicists look closely at the smallest building blocks of physical reality, the spinning atoms, darting electrons, and elusive quarks, they find that they are mostly vast expanses of empty, vibrating space. As science has probed deeper into the nature of solid matter, it hasn't found the impenetrable billiard balls we once imagined. Instead, it has found hazy probability clouds, shifting fields of potential, and elegant mathematical relationships. It is a stunning paradox. The deeper we look into the core of the physical world, the less physical it appears to be. It begins to look less like rock and stone, and more like mathematics, logic, and vibrating information. Consider, as you rest, the image of an ancient green forest. When an oak tree grows over centuries, it is not simply reading and following a static blueprint stored on an invisible hard drive. It is computing its own physical form in real time. The acorn seed interacts with the moisture in the soil, the shifting temperature of the spring air, and the changing angle of the sunlight filtering through the canopy. Every cellular division within the growing wood is a live calculation, taking into account the surrounding environment, the instructions of its genetic code, and the availability of water and nutrients. The towering tree is not a simulation running blindly in a machine. It is the physical manifestation of a complex, ongoing living computation. And the forest itself, taken as a whole, is an interconnect network of millions of these simultaneous living computations. The trees communicate with one another through underground fungal networks, exchanging nutrients and calculating the optimal distribution of stored energy to ensure the health of the whole woodland system. The forest is computing itself into existence. The dark ocean is computing its rolling tides and complex currents based on the gravitational pull of the orbiting moon and the radiant heat of the distant sun. The atmosphere is computing the daily weather, solving a chaotic, beautiful equation of pressure, temperature, and moisture. There is no central processor hidden deep in a mountain dictating these movements. The processor is not in one place. The processor is everywhere, in everything. And so, lying here in the quiet, we can return to the idea of a computational universe, but we must first strip away the mechanical baggage of our current technology. We strip away the sprawling server farms, the motherboards, the silicon processors, and the roaring cooling fans. When all of that metal and plastic is gone, we are left with the core idea that reality itself is computational, that it is informational at its deepest root. But it is a kind of computation that happens everywhere, all at once, in every microsecond of passing time. It is not localized or trapped inside some metallic mainframe in the sky. The computation is the living universe itself. Every atom interacting with another atom is a tiny calculation. Every autumn leaf falling from a high branch, calculating its spiraling path through the resisting air and responding to the pull of the Earth's gravity, is a fluid computation. Every star burning in the night sky is calculating the furious equations of nuclear fusion, balancing the inward pull of its own gravity with the outward explosive force of its atomic energy. We cannot rule out the possibility that the universe is not a rigid program running on a giant computer, but rather that the universe itself is the living computation. It is not impossible that it operates as a self-rendering, self-sustaining process of weightless information, constantly unfolding into the reality we see and touch. This realization shifts our perspective away from a cold, mechanical isolation and guides us toward an elegant connection to all living things. We are not simulated programs trapped inside a machine built by some distant, uncaring alien intelligence. We are a breathing part of the ongoing living computation itself. We are the universe experiencing its own existence, calculating its swirling possibilities, and exploring its own boundless potential through our own wondering eyes. There is a settling peace to be found in this quiet realization. Lying here tonight, you do not need to worry about the cosmic machine breaking down or freezing up in the dark. You do not need to fear the cosmic server farm losing power, running out of memory, or crashing into darkness. The unfolding of our reality is a natural property of existence itself. It is as effortless and automatic as your own gentle breathing in this moment. Breathing slowly in and breathing softly out, your chest rising with life and falling into rest. The universe does not need to strain or struggle to exist. It simply exists, continuously calculating its next moment, its next breath of rustling wind, its next igniting star, its next thought. And you, lying here in the comforting dark of your own room, are an inseparable part of that grand cosmic unfolding. As you sink deeper into the comfort of your bed, take a moment to feel the firm support of the mattress beneath your body. It feels reassuringly solid. It feels real. And it is real. But its comforting reality is not based on it being an unchanging, permanent thing. Its reality is based on the miraculously stable, invisible web of information that tells those trillions of atoms to hold together, to push back against the pull of gravity, to support your resting weight, and to provide you with this safe place of rest. The woven softness of your blanket pulled up to your chin, the cool, still air hovering in your quiet room, the muffled sounds of the deep night drifting in from just outside your window. All of these ordinary things are flowing patterns of information, rendered and experienced by you alone in this fleeting moment. You do not need to understand the mind-bending math that hums behind it all. You just need to rest here and gratefully experience it. You just need to keep your eyes closed, breathe naturally, and allow it all to be exactly as it is. In our unhurried wandering tonight, we have moved past any lingering need for a hidden, mechanical, cosmic motherboard. We have moved past any imagined need for celestial silicon chips and endless miles of physical wires. We have recognized that the metaphor of the human-made computer is far too small, far too heavy, and far too limiting a concept for the elegant, weightless reality that we actually inhabit. But this floating understanding brings us to a new precipice of thought. As you hover here, feeling relaxed, resting on the blurring edge of sleep, surrounded by the effortless rendering of your own reality, a new question almost shyly presents itself to your resting mind. It is not an urgent or demanding question, and it does not require any immediate answer from you tonight. It is just a light, passing thought, something to let drift like a small cloud across the tranquil space of your resting mind. If there truly is no heavy, physical hardware hidden away somewhere in the freezing cosmic dark, if there is no whirring, overheating machine hidden behind the dark velvet curtain of the night stars, if our universe isn't a coded program running on some vast alien server farm, then how, you might wonder, is all of this intricate existence actually happening around us right now? If the core of our reality is indeed weightless information, ongoing computation, existing without the need for any physical stuff to make it all go and keep it running. If there is no physical, mechanical machine out there rendering the beauty of the world around us, then what, exactly, in the deepest, quietest heart of the cosmos, is actually doing all this computing? We've been lingering at the edge of the quantum cliff, looking down into a world where the rules we grew up with no longer apply. It is counterintuitive, perhaps even impossible to fully internalize. Yet, it is the bedrock of everything. Every breath you take, every quiet thought that drifts through your mind as you settle into the stillness of the night, is underpinned by these microscopic uncertainties. As you lie there, feeling your steady pulse and the heavy weight of the blankets pressing down on you, you are resting on a foundation of shimmering probabilities. The wooden floor beneath you, the cool glass of the window holding back the dark, the very air slowly filling your lungs. All of it, every tangible piece of your environment, is built upon a restless subatomic realm. But the story of quantum mechanics does not stop with particles existing in two places at once, or the observer effect collapsing hazy possibilities into a measurable reality. The early pioneers of the quantum world, giants like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger, had opened a door that could never be closed again. As the 20th century wore on, a new generation of physicists kept pushing the boundaries of this strange territory. They stared deep into that mathematical abyss, tracing complex equations across chalkboards, seeking a cohesive narrative to make sense of the paradoxes. The mathematics worked flawlessly. The predictions were staggeringly accurate. But equations alone do not provide meaning. These scientists wanted to know not just how the universe behaved mathematically, but why it behaved this way, and what it meant for the substance of reality itself. They were looking for the bottom of the rabbit hole. Into this intellectual search steps a man who remains one of the most brilliant yet underappreciated figures in physics outside of strictly scientific circles, John Archibald Wheeler. Wheeler was a visionary, a scientist who saw the universe not merely as a machine to be dismantled, but as an endless frontier of mysteries waiting to be understood. He lived through the most transformative era in the history of physics, witnessing firsthand the fiery debates that tore down the clockwork Newtonian worldview and replaced it with a shifting landscape of probabilities and paradoxes. Wheeler absorbed the shockwaves of both Einstein's relativity and Bohr's quantum mechanics. He worked closely with both men, absorbing their philosophies and their mathematical rigor. He knew, better than almost anyone, that the quantum revolution could not be rolled back. The comfortable innocence of the classical world was gone forever. It had to be followed to its logical, no matter how bizarre, conclusion. Serving as a crucial bridge between the early quantum titans and the modern era of theoretical physics, Wheeler possessed a rare gift for finding poetry hidden within dense thickets of mathematics. Where others saw only abstract symbols and cold calculations, Wheeler saw sweeping narratives about the nature of existence. He popularized the term black hole, giving a terrifying mathematical anomaly a name the public could finally hold on to. He was a philosopher of science in the truest sense, unafraid of asking uncomfortable questions. As he grew older, and as his understanding of the universe deepened, his thoughts shifted away from the simple mechanics of how particles interacted towards something even more fundamental. He no longer just wanted to know how the cosmic gears turned. He wanted to know what the gears themselves were made of. Wrestling for decades with the implications of quantum mechanics, he sought the bedrock beneath the bedrock. If, as quantum theory suggested, particles are nothing more than waves of probability until they are measured by an observer, what is the universe actually constructed from? What is the fundamental material of reality? For millennia, human beings have instinctively assumed that the universe is made of matter and energy. Solid stuff moved around by invisible forces. Even in the early days of quantum mechanics, people desperately clung to the belief that there were still tiny building blocks at the bottom of it all. They might behave strangely. They might exist in a confusing haze of uncertainty. They might teleport or become entangled across vast distances, but surely they were still physical things, microscopic grains of sand scattered across the cosmic beach. But as Wheeler looked deeper, he began to suspect this deeply ingrained assumption was backwards. Our intuition about the physical world might be a spectacular trick of the light. The stuff of the universe, the matter, the mass, the tangible particles, wasn't fundamental at all. The material world was merely a downstream byproduct of something invisible, abstract, and profound. In 1989, after a lifetime of exploring the extremes of the cosmos, this realization finally crystallized into a single theory. The year 1989 was the dawn of the information age. Early global computer networks were beginning to exchange data at the speed of light. Society was rapidly waking up to the idea that the abstract concept of information was a transformative currency every bit as real as oil, steel, or electricity. We were learning to encode complex realities, music, images, entire libraries of text, into microscopic sequences of ones and zeros. It is fitting that in this cultural moment, as the world was learning the language of binary code, Wheeler introduced a concept that forever changed how theoretical physicists view reality. He distilled decades of agonizing thought and complex mathematics into a phrase so simple it sounds like an ancient Zen koan. He called it from bit. 3 small words holding a revolution in thought. Let that phrase settle into the dark space of your mind as the shadows lengthen across your room. From bit. It is deceptively simple, yet it carries enough conceptual weight to dismantle our everyday understanding of the physical world. Let's unpack exactly what he meant by this. When Wheeler said he meant everything, literally everything. Every subatomic particle vibrating in the void, every invisible field of magnetic force, every carbon atom currently making up the cells in your body, the blankets resting heavily over you in the dark, the ancient continents, the burning nuclear furnace of the sun, the silent stars scattered across the galactic plane. Every physical piece of reality, from the smallest hypothetical quark to the largest galactic supercluster. All of that physical reality is the it. And when he said bit, he meant exactly what computer scientists mean, a binary digit. A fundamental choice between 2 alternatives, a yes or a no, a 1 or a 0, true or false. It is the simplest distinction that can possibly be made in the universe. With from bit, Wheeler proposed a radical inversion of reality, that all physical things, every solid in the universe, derive their existence, their mass, their location, their physical properties from abstract information, from bits. The universe is not made of solid stuff. It is made of answers to questions. It is, at its core, made of information. Recall the bizarre nature of quantum measurement we explored earlier. A particle simply does not possess a definite state. It has no exact location, no precise momentum, no defined spin, until it is observed. Before the moment of observation, it is pure mathematical potential, a smeared-out superposition of all possible states at once. It is a ghostly maybe. When a measurement is finally taken, you are essentially asking nature a direct question. Is the particle located here or over there? Is its quantum spin pointing up or down? Nature is forced to provide an answer, yes or no, up or down, here or there. That final answer is a single piece of information, a bit. To understand how a seemingly objective reality could possibly emerge from something as weightless as yes or no answers, imagine the classic parlor game of 20 questions. In the traditional version of the game, one person thinks of a specific object, and the other person attempts to guess what that object is by asking only questions that can be answered with a yes or a no. With each binary answer received, each new bit of information gathered, the vast realm of all possible objects shrinks. The possibilities narrow down bit by bit until only one unavoidable truth remains. Now, imagine a quantum version of this game. In this version, the person answering the questions hasn't actually decided on an object at all before the game begins. Their mind is blank. Instead, as the questions are asked one by one, they simply provide answers on the fly, making sure only that their current yes or no does not logically contradict any of their previous answers. In this strange scenario, the object does not exist at the start of the game. It doesn't exist until the specific sequence of questions forces it into being. The final object that is guessed at the end of the game is nothing more than the logical conclusion of those bits of information summoned out of the void by the act of interrogation. This concept suggests that the universe plays this elaborate game with us. The accumulation of billions upon billions of yes or no answers gathered through countless microscopic and macroscopic interactions over time creates the consistent illusion of what we perceive as solid reality. The physical world is not the foundation of the universe. It is merely the end result of an ongoing process of information gathering. The physical it comes directly from the abstract bit. This shifts our view of the cosmos, turning physics from the study of moving matter into an advanced branch of information theory. Reality is less like a blind, mechanical clockwork ticking away in the dark, and more like a cosmic simulation, generating the convincing illusion of solidity, texture, and weight through an ongoing stream of binary data. But there is a second, more impactful half to this idea, one that circles directly back to you, lying there, listening in the dark. If the physical universe is fundamentally composed of information that is generated by observation, then we must confront a logical necessity. Information requires a reader. A book is nothing more than arbitrary stains of ink on sliced wood pulp until a human mind reads it and extracts the story. A radio wave is just silent electromagnetic radiation until a receiver decodes it into music. Information, by its very definition, implies a relationship between a sender and a receiver. It implies an act of comprehension. It requires an observing mind to give it meaning. Therefore, the argument follows, the universe cannot exist in any meaningful physical state independent of observation. It requires us. It requires observers to ask the questions, to force the universe to collapse its probabilities, and to process the resulting answers. This beautiful concept is often called the participatory universe. Under this paradigm, we are not passive spectators watching a pre-written cosmic play from the cheap seats. We are not meaningless visitors wandering through a dusty museum that existed long before us and will persist long after we are gone. We are vital participants. By the act of looking, measuring, and interacting with our environment, we are drawing the universe into existence, moment by moment. Envision the entire span of cosmic history not as a chronological line, but as a sweeping curve. The line begins at the top left, representing the fiery birth of the cosmos in the Big Bang. As the line curves downward, unimaginable eons pass in silent darkness. Space expands. The initial heat dissipates. Matter cools and condenses. Gravity pulls gas into swirling islands of light, forming the first galaxies in the freezing emptiness. The line then begins to sweep back up the right side. Within those galaxies, dust and heavier elements coalesce. Planets form around burning suns, and on at least one rocky sphere, liquid oceans pool. Chemical reactions spark. Life slowly evolves, growing more complex with each passing epoch. And at the very top of the right side of this grand curve, millions of years of evolution result in the development of a conscious mind. An eye opens, an eye that looks directly back across the vast space, back toward its own origin, looking back at the stars, back at the cosmic microwave background, back toward the Big Bang itself. That conscious eye is us. The universe, over 14 billion years of blind time, slowly engineered a way to look at itself, and in the very act of looking, it makes its own history and its own physical reality concrete. We are the required mechanism by which the universe pulls itself out of an undefined quantum superposition and into a defined reality. This is an intimate vision of the cosmos. You are not an accidental speck floating in an indifferent void. You are a foundational component of reality's architecture. Without observers to interact with the environment, there are no questions asked of nature. There are no answers given. There are no bits of information generated. And without the bits, there is no physical it. Without the observer, the universe remains trapped in a perpetual state of ghostly potential. It is a dream with no dreamer, a story with no reader. Think about what this personal physics means for you right now. As you rest in your bed, sinking deeper into the heavy stillness of the night, you are still constantly interacting with your environment. Your senses, even when dimmed, are processing a continuous stream of information. The soft feeling of the sheets against your skin, the subtle temperature of the air, the muffled sound of the wind outside your window. You are continuously participating in the ongoing creation of your local reality. When you open your eyes in the dim light and look at the familiar shape of a lamp or the dark silhouette of a shadow in the corner, you are instinctively asking nature a question. By processing those stray photons of light, your brain forces the quantum potentials of that specific area of space to collapse into a defined state. You continuously pull the it out of the bit, anchoring your bedroom in physical reality. When concepts like this were first introduced, they were met with intense skepticism by many in the scientific establishment. It sounded too mystical, blurring the lines between objective science and speculative philosophy. But as our understanding of quantum information, computing, and entanglement has grown exponentially over the last few decades, this information-centric vision seems less like a philosophical thought experiment and more like a prophetic insight into nature's underlying architecture. Today, entire fields of theoretical physics are dedicated to studying the universe primarily through the lens of information. Physicists explore how quantum entanglement acts as a hidden network connecting the farthest reaches of the cosmos, and how supermassive black holes might store the information of everything that falls into them on their two-dimensional event horizons. The radical idea that information, rather than matter or energy, is the fundamental currency of reality is now at the cutting edge of modern scientific inquiry. It all stems from the realization that the complex equations of the atom weren't describing a tiny machine clicking away in the dark. They described a dynamic conversation between the observer and the observed, written in the universal binary language of existence and non-existence. This brings us to a place of comforting quiet. You are not separate from the world around you. You are not an isolated entity looking out through a window. You are inextricably woven into the very fabric of existence. You are the universe intimately experiencing itself, constructing reality one bit at a time. As you drift closer to the edge of sleep and the rigid boundaries of the waking world begin to soften and blur, let go of the lonely idea that you are a solitary mind isolated in an unfeeling world. Embrace the empowering thought that you are a vital participant in the ongoing creation of reality. Every quiet perception, every breath, every heartbeat is a brushstroke on the canvas of existence. You are holding your world together simply by being here to witness it. Yet, as beautiful and empowering as this participatory vision of the universe is, it leaves a subtle chill in the quiet air of the room. An unsettling question floats in the stillness, waiting patiently in the shadows just beyond your bed. If physical reality is truly generated by our observation, by our continuous processing of quantum information, we are forced to carefully consider all the things we are not currently observing. We have to wonder, with a twinge of primal unease, about the silent spaces where the light of our attention does not currently reach. If the solid it truly comes from the abstract bit, and the bit requires a conscious reader, what happens to the text when the reader finally closes their eyes? What happens to the structure of your room when you finally surrender to the dark and drift into sleep? What happens to the physical world when you simply stop looking at it? We are comfortable with the solid reality of the things directly in our line of sight. But this unavoidable logic of quantum mechanics forces us to confront an unsettling question about the dark space. Just outside your field of vision, think about the space right behind your head. You cannot see it. You can feel your head sinking into the pillow, the soft fabric against your skin, or the gentle air moving across your shoulders. But visually, tangibly, the space behind you is a mystery right now. Our brains, trained by centuries of classical physics and a lifetime of everyday experience, tell us the room simply continues exactly as we left it. We assume, with unwavering certainty, that the wall is still in place. Behind us, the wooden door remains closed, and the world outside the window is still spinning through the vastness of space. We assume a solid reality, a permanent architecture existing independent of our attention. But the mathematics of quantum mechanics suggests a much softer possibility. It suggests that the unobserved parts of your room, the shadowed corners of your home where your eyes cannot reach, are not locked into a definite state. Instead, they exist in a state of quiet suspension. They are a hum of mathematical potential. They are waiting, formless and free, in the velvet dark. It is a thought that troubled some of science's greatest minds, sparking decades of impassioned debate among the founders of modern physics. Albert Einstein, frustrated by the implications of the theory he helped create, famously asked a colleague, "Do you really believe the moon is not there when you are not looking at it?" It seems like a ridiculous query. Of course the moon is there. We feel its gravity dragging the heavy oceans across our shorelines. We know it reflects the sun's brilliant light down onto the sleeping Earth. But in the mathematical interpretation of quantum mechanics, before an observation is made, the physical universe, including the moon, just like a tiny electron or a fleeting photon, is merely a localized wave of probability. It is not a solid rock. It is a mathematical abstraction floating in an ocean of possibility. It is only when someone or something looks at it, measuring its reflected light against a sensitive retina, that this undefined wave collapses instantaneously into the cratered sphere we know so well. Before that crystallizing moment of observation, it is nothing but smeared out potentiality, existing nowhere and everywhere within its probable bounds. If you are still awake, listening to the quiet rhythm of the night, tell us in the comments how it feels to entertain the idea that you generate your own reality. It is an almost dizzying responsibility to think about in the silent hours of the night, but it is also beautiful. You are not merely a passive passenger riding blindly through a cold, indifferent universe. You are the architect of your waking world. Every glance you cast across a room, every breath you take, is a literal act of creation, pulling the textured world out of the mist of quantum chance. But if your eyes are already growing heavy, if the weight of the long day is pulling you down into the softness of the mattress, that is exactly as it should be. You do not need to hold the world together right now. You do not need to keep the burning stars pinned to the dark fabric of the sky, or keep the moon locked in its orbital path. You can simply let it all go. You have permission to let the demanding edges of your waking reality blur, soften, and fade away. You can allow the familiar walls around you to dissolve back into that quiet sea of probability. As you drift off to sleep, slipping beneath the threshold of conscious awareness, you are not disappearing. You are simply returning your consciousness to the unobserved state of potential. Let the noisy world take care of itself for a little while. It does not need your weary eyes to watch it or maintain it. It will be resting out there in the dark, waiting for you, ready to be rendered all over again in the golden wash of morning light. For those still traveling with me through the fading hours, let us go deeper into the mystery of this unobserved space. Think of the unseen universe outside your immediate perception as an undeveloped photograph. Imagine an old mechanical film camera, the kind with intricate dials and a satisfying advance lever. The metal shutter has snapped open and clicked shut in a fraction of a second. The silver halide film has been briefly exposed to the light of the outside world. The information of the scene is all there, captured and suspended within the chemical emulsion. The detailed potential for the final image exists inside that light-proof canister. But until that exposed reel of film is carefully extracted, taken into the red-lit sanctuary of a darkroom, and submerged into the chemical bath of liquid developer, the image remains invisible to the eye. It is nothing more than the latent promise of a picture. The unobserved universe, the spaces existing just outside your peripheral vision, is exactly like that unrendered roll of film. It holds all the information, all the swirling probabilities of what the room or the cosmos could possibly be, but it remains dark, undefined, and waiting for completion. Your attention, your conscious observation, acts as the developer fluid. When you look up at the canopy of stars, or when you twist a doorknob and step across a threshold into a new room, or even when you simply flutter open your eyelids in the morning light, you are developing the sweeping photograph of reality in real time. You are pulling the colorful image out of formless potential. You are making the world real just by standing within it. Or imagine a pristine white envelope, sealed and resting quietly on the scarred surface of a wooden desk in an otherwise empty room. You know for a fact it contains a folded letter. You might even have an educated guess about exactly who sent it, the nature of the handwriting, and the specific words written on the pages hidden inside. But until you physically slide your finger under the paper flap to break the glued seal, pull out the paper, and unfold the sheet, the contents of that letter exist in a state of pure superposition. It could contain breathtaking, life-changing news. It could contain heartbreaking sorrow. It could be a mundane utility bill, a passionate love letter penned years ago, or simply a blank sheet of paper included by mistake. In the theater of your mind, and indeed in the mathematical reality of our probabilistic universe, all these divergent possibilities exist equally and simultaneously. The mathematics of quantum mechanics suggests that reality operates in this counterintuitive way, but scaled up to a cosmic magnitude. The entire universe is essentially a sprawling collection of sealed envelopes. The physical state of an object hidden inside a locked box, the unpredictable position of an electron buzzing around a nucleus, the violent reality of an unseen spiral galaxy millions of light years away. They are all, effectively, sealed away from reality. And the revelation is not merely that our minds don't happen to know what is hidden inside. It is that the universe itself hasn't decided yet. The universe holds its breath, delaying the final rendering until the moment the envelope is irrevocably opened. The act of observing and measuring forces the indecisive universe to make a hard choice, collapsing all the ghostly possibilities into a single undeniable truth that can never be undone or return to the realm of probability. There is something profoundly peaceful about resting with this paradigm-shifting idea. It means the universe is not the exhausting, grinding clockwork machine that classical physics once assumed it was. It is not churning away its iron gears in the cold dark rendering and maintaining the position of every atom across billions of light years, regardless of whether anyone is ever there to witness the effort. Instead, the cosmos is fluid, flexible, and almost lazily efficient. It seems to only render what needs to be rendered in any given instant of observation. When you finally close your tired eyes in a dark bedroom, the universe does not waste its infinite energy maintaining the intricate floral patterns of the wallpaper hidden behind the tall oak dresser. Nor does it bother calculating the sharp angles of the shadows cast across the floorboards by the heavy furniture. It simply lets them all fade away. It lets the unseen room relax back into a formless hum of probability. It is as if the ancient universe itself is taking a long, slow breath alongside you, resting its tired bones, powering down its computational engines, and waiting in the velvet dark for you to call it all back into vibrant existence with your next waking glance. Let us linger here just a little longer, floating together in the undefined spaces of the unobserved universe. Taking the time to actually understand this concept intuitively, to feel it rather than just think about it, changes how we interact with the dark and the unknown. So often in our busy, illuminated lives, we are culturally and evolutionarily conditioned to be afraid of what we cannot see. We fear the pitch-black room at the end of the hallway, we shudder at the lightless depths of the midnight ocean, and we feel an existential dread when contemplating the empty space yawning between the stars. We reflexively populate the unobserved world with our worst anxieties, imagining hidden monsters, stalking predators, and unseen dangers lurking in the void. But if the mathematics of quantum mechanics is indeed showing us the fundamental nature of reality, then the unobserved world is not full of terrifying threats at all. It is, in fact, full of quiet, shimmering possibility. It is a blank canvas waiting for the brushstroke of your attention. It is a forgiving place where nothing is fixed, nothing is predetermined, and therefore, nothing is inherently frightening. The dark is not a devouring void. It is simply unrendered potential, waiting patiently in the wings like actors behind a heavy velvet curtain. It is a comforting space of resting energy, a protective blanket woven out of theoretical math and beautiful chance. Imagine walking alone through a dense, towering forest in the dead of a moonless night. The sharp beam of your flashlight cuts a trembling path through the suffocating darkness. The rough bark of the pine trees, the patterns of damp, decaying leaves scattered on the cold ground, the gnarled roots protruding just ahead of your boots. They all leap into undeniable existence. The second the cone of light hits them, they become instantly real, fixed in space and time. But what about the thousands of square miles of dense forest entirely outside that searching beam? Are they all still out there, solid and silently waiting in the pitch black? The beautiful quantum perspective suggests that the moment they fall outside the beam of your attention, the great trees return to a less defined state. The millions of trembling leaves are no longer fixed in one specific position. The groaning branches are no longer locked in place. The unseen forest becomes a mathematical ghost of itself, a probabilistic cloud of what it might be, resting in suspended animation, waiting for the sweeping beam of your light to force it to be solid all over again. This is not a frightening or isolating thought. It is a wildly magical one. It means the physical world around you is inextricably responsive to your presence. You are not wandering lost through a cold, uncaring universe. You are walking through a pulsating, living world that responds instantly to you. And your quiet awareness is the magic that brings it all into high-definition focus. Think, too, about the mind-bending scale of this unobserved universe. The overwhelming majority of the sprawling cosmos is unobserved by any human eyes, and perhaps by any conscious eyes at all. Consider the billions of swirling spiral galaxies, the gas-choked interiors of stellar nebulae where new suns are being forged, and the desolate expanses of the lightless intergalactic void stretching between them. If a dying star suddenly collapses and detonates in a violent supernova a billion light years away, and its traveling photons won't reach the glass mirrors of telescopes on Earth for another billion years, what is the objective state of that explosion right now, at this very moment? Is it a fiery, concrete event burning in the deep dark, or is it merely an unresolved wave of shifting probability, rippling through the cosmos, waiting across unimaginable eons for a polished lens or a sensitive retina to catch its ancient light and collapse its reality into undeniable fact? From this perspective, we are a fragile point of conscious observation floating adrift in a churning ocean of the unknown. We are like a single glowing pixel illuminating a pitch-black screen the size of the entire world. But that lonely pixel is fundamentally crucial to the whole system. Our conscious observation is the iron anchor that holds our local reality together. We, with our searching eyes and our questioning minds, are the keepers of the physical world. And yet, despite carrying that cosmic responsibility, the beauty of our biology is that we do not have to hold it all together all the time. We are evolutionarily designed to inevitably let it all go. Sleep is not just physical recovery. It is our daily retreat back into the forgiving embrace of the unobserved universe. It is our trusting surrender to the swirling possibilities of the quantum wave function. When you finally lie down in your bed, pull the warm covers up over your shoulders and close your tired eyes, you are choosing to stop observing the demanding external world. You are choosing to stop collapsing the wave. You slowly pull your attention inward, away from the painted bedroom walls, away from the cold glass windows, and away from the pale moon hanging in the sky, and you simply let them all dissolve into the background. You grant the hard-working universe a well-deserved moment of silent rest. You allow the solid room to become a sealed white envelope once again, a latent photograph resting safely in the protective dark of the canister. And in granting the physical world that momentary peace, you grant yourself that same healing rest. You allow your own mind to become undefined, unmeasured, and free from the relentless constraints of maintaining a singular waking identity. This is the unshakable comfort of the silent night. It is a sacred, transitional time when the pressure of maintaining a concrete reality is lifted off your shoulders. The frantic world immediately outside your bedroom window does not need you to watch it or worry about it right now. The paved streets, the glowing streetlights, and the passing cars can safely blur back into a hazy state of quantum probability. The distant cities miles away can hum quietly with unrendered potential. The ancient mountains sleeping on the horizon can forget their crushing stone weight for a few fleeting hours. You are safe here in this cocoon, resting in the very center of your own quiet collapse of reality. You are the essential observer who has deliberately chosen to close your eyes and let go of the reins. And as you do, the vast universe breathes a long, echoing sigh of relief right alongside you. Let the unbroken darkness of the quiet bedroom be a comforting blanket of unmeasured potential covering your resting body. Let the ringing silence in your ears be the literal sound of the universe, resting in a delicate state of superposition. Never forget that you are an integrated part of this responsive cosmic system. You are the developer of the grand photograph, the opener of the sealed envelope of reality. But right now, for these next few hours, the red-lit darkroom is closed and locked. The stack of unopened mail is waiting harmlessly in the dark on the desk. There is nothing you need to figure out or decide tonight. Nothing you need to observe or measure. Nothing you need to force into concrete being. You are allowed to simply exist right now as a resting, formless wave of thought. And for those still with me in the enveloping dark, holding quietly onto the frayed edge of conscious wakefulness, lingering in that liminal twilight space that exists just between the solid world and the washing wave of deep sleep. For those of you still listening to the cadence of my voice in the quiet of the room, Modern physicists actually have a specific name for this personal, observer-created version of reality. Imagine a timeline folding backward into the early 2000s. The world was moving faster than ever, wires connecting continents, data rushing silently through the air. It was an era of relentless connectivity, a time when humanity tried to map every measurable fact of existence. We built grand networks, launched deep space satellites, and constructed massive colliders beneath the Earth to smash particles together in search of absolute truths. The human genome had just been sequenced. The hum of servers were promised a world that could be perfectly categorized from the outside looking in. Science seemed to be assembling the final pieces of an objective puzzle. But in quiet university offices stacked with neglected papers, a few physicists sat in deep silence, pondering the nature of reality and the stubborn paradoxes that standard theories could not resolve. Physicists like Christopher Fuchs and Rüdiger Schack didn't look out at the sprawling objective world. Instead, they looked inward. They watched dust motes drift in the afternoon light and listened to the steady rhythm of their breathing. They were thinking about you. They were thinking about the observer, the breathing, subjective human being that had been systematically erased from the equations of physics for centuries. Reaching into the dark to touch the abstract shape of the universe, they returned with something unexpected. Building on the probability theories developed mathematically centuries earlier, they formulated a new way to look at the stubborn mysteries of the quantum world, a framework known as quantum Bayesianism, or simply Cubiism. Cubiism does not ask you to stretch your imagination to the breaking point. It doesn't require a multiverse of infinitely splitting realities, where every decision spawns an exhausting labyrinth of paths not taken. It doesn't ask you to believe in invisible pilot waves dragging reality along against its will, like ghostly currents beneath the surface of the universe. It asks for something much simpler and more intimate. It asks you to look at your own mind. It asks you to consider that the mysterious wave function, the mathematical ghost haunting physics since Erwin Schrödinger formulated it in 1926, is not a tangible thing out in the physical world. It is not a physical wave crashing on the unseen shores of reality, nor a magical mist guiding particles through the microscopic dark. It is not an objective structure holding the atoms of the universe together while you aren't looking. In the quiet logic of Cubiism, the wave function is simply a tool. It is a catalog of your personal beliefs, a map of your expectations and probabilities. Much like how a meteorologist uses current data to estimate the likelihood of rain, the wave function is a mathematical diary of what you, the subjective observer, expect to experience next. It is the hum of your intuition formalized into elegant, rigorous equations. It measures your uncertainty rather than the objective state of a distant particle. Take a slow, deep breath in and let it out slowly into the dark. Feel the weight of that idea settling over you. The wave function is not a property of the world. It is a property of your relationship with the world. It is your personal guidebook to the universe, constantly updating with every new piece of information you gather, every sensation you let wash over you, every measurement you choose to make. When you look up at the stars, when you feel the blankets against your skin, when you hear your steady breathing in the dark, you are updating your catalog. You are interacting with the world, and the world is responding, bending to meet your gaze, shaping itself around your presence. Every photon of starlight that reaches your eye is a completed transaction, a probability collapsed into a definite experience. The Cubeists proposed that quantum mechanics is not a user manual for how the universe works in your absence. It doesn't describe a cold, mechanical reality ticking away in an empty room, indifferent to whether anyone is there to witness it. Instead, it is a manual for how you should place your bets on what you will experience when you touch the world. It is a user's guide for the observer, navigating an inherently unpredictable cosmos. We cannot prove there is a grand universal stage where events play out identically for everyone. It is not impossible that objective reality is not what we historically assumed it to be. We cannot rule out the idea that reality is strictly personal. The universe you inhabit might be uniquely yours, shaped by your distinct experiences, your history, and your private catalog of beliefs. It is not inconceivable that it is a custom-made cosmos tailored to your dimensions. Think about the room you are in right now. The soft shadows gathering in the corners where the wardrobe meets the wall. The muffled sounds of the night outside, reduced to a gentle rhythm. The exact temperature of the air on your face. The texture of the pillow beneath your head. The specific way the blanket drapes across your shoulders. In the framework of cubism, this room, exactly as you experience it, does not exist independently of you. It is a collaboration between you and the cosmos. A private conversation happening in the dark. If someone else were to walk into your room, they wouldn't be stepping into your universe. They would be bringing their own. They would carry their own wave function and their own internal catalog of probabilities, built over a lifetime of different sensory inputs. They would experience a slightly different room, a different temperature, a different reality. They might feel a draft you don't notice, or focus on a sound your brain has successfully filtered out. Everyone lives in a slightly different universe. We wander through our personal realities, occasionally brushing against each other, sharing experiences through the clumsy bridge of language, and updating our beliefs based on our interactions with one another. But the deep, true center of reality belongs entirely to the observer. It belongs to you. No one else has access to the precise sensory and cognitive landscape you are inhabiting right now. Breathe in, drawing the quiet world toward you. Breathe out, letting your expectations settle into the mattress. This radical idea that you are the center of your own personal universe might sound lonely at first, a kind of philosophical isolation. But if you let it settle, there is a deep comfort in it. It means you are essential. Without you, your universe simply does not exist. The quantum state of the world is not a cold, indifferent machine grinding away in the void. It is a living relationship, a continuous, dynamic dance between you and everything else. Your presence brings your reality into sharp relief. When you close your eyes, you aren't disappearing from reality. You are simply closing the book on your observations for a little while. You let the catalog rest. The sharp edges of the awake world dissolve into a gentle haze of sleep. The rigid probabilities that you maintain throughout the day, the constant mental calculations of distance and sound and light, are allowed to softly unravel. You don't need to hold the universe together while you sleep. It isn't a heavy physical burden you carry on your shoulders. It is just a set of beliefs, waiting quietly for you to open your eyes again. It requires no effort, no vigilance. It simply waits, suspended in the dark. Years afterward, one of the field's sharpest voices, David Merman, came around to it. One philosophical goal of cubism is to put the scientist back into science. For centuries, starting perhaps with the classical physics of the Enlightenment, we tried to describe a universe operating behind thick glass, completely indifferent to our gaze. We pretended we could be a view from nowhere, looking down at the cosmos without being part of it. But the quantum world refused to be ignored. It pushed back against the glass. It demanded to be seen, showing us through decades of baffling experiments that the act of experiencing is the very foundation of what is real. You are the scientist of your own life, the observer of your own rest. Let your body sink deeper into the mattress. Feel the steady support beneath you. This, too, is an observation, a piece of reality you are actively creating right now. The sensation of gravity holding you safely in the center of the bed, the softness of the pillows cradling your neck, the gentle rise and fall of your chest. You are cataloging these peaceful feelings, updating your beliefs, confirming with every slow breath that you are safe. You are warm. You are resting exactly where you need to be. As the modern world grew louder, exponentially more crowded, and endlessly connected through glowing screens, Cubism offered a necessary retreat into the self. It reminded us that no matter how vast the universe seems, the only reality you will ever truly know is the one that happens to you. The overwhelming scale of the cosmos is secondary to the immediate, undeniable truth of your own quiet breathing. David Mermin wrote elegantly about the illusion of the objective world, the persistent, deeply ingrained belief in a single, true reality independent of human perception. For years, physicists had relied on his famous summary of the Copenhagen interpretation: shut up and calculate. But eventually, the desire to understand the deeper meaning of those calculations led him to the subjective embrace of Cubism. Cubism gently strips away the illusion of an objective reality, leaving something much more beautiful. It leaves you. It leaves your experiences, your sensations, and your personal passage through the infinite field of probabilities. Imagine the wave function again, not as a physical wave moving through space, but as a translucent map of your own mind. When you are awake, the map is sharp, filled with firm expectations and solid beliefs. You know where the floor is. You know the sound of your name. You expect the sun to rise and the ground to hold your weight. You are constantly collapsing probabilities into definite facts, pinning the universe down with your attention. But as you drift toward sleep, the map softens, the points of light blur. Your expectations loosen their grip on the world. The probabilities smear out, becoming fluid and forgiving. You are no longer forcing the universe down a single, rigid path. You are letting it return to a state of quiet, undisturbed potential. You are allowing the wave function to spread out, vast and unmeasured. You are unclenching your mind. You are releasing the need to know, to observe, to measure. Breathe in the quiet potential. Breathe out the need for certainty. It is okay not to know what happens next. It is okay to let the catalog close for the night. The universe will not unravel while you rest. It will simply wait, suspended in gentle probability. The stars will continue their slow wheeling dance in the dark. The earth will continue its rotation. But for you, in this room, all of that ceases to demand your attention. This is the quiet gift of Cubism. It frees you from the burden of an unyielding reality. It tells you the world is flexible, responsive, and intimately shaped by your interactions. And when you choose to withdraw your interactions, when you choose to simply lie still in the dark and breathe, the world rests with you. It matches your stillness. It honors your silence. Right now, your universe is shrinking down, becoming wonderfully small and intimate. It is shrinking to the size of this room, to the borders of your bed, to the steady rhythm of your own heart. The infinite possibilities of the vast cosmos, the billions of galaxies, and the endless sweep of deep space are folding up, packing themselves away into this single, peaceful moment of rest. They do not matter right now. Only this moment matters. There is nothing else you need to observe tonight. There are no more measurements to take, no more beliefs to forcefully update, no more data to collect from the rushing world. There is only the quiet observation of your own comfort. You feel the heaviness settling into your eyelids, a personal observation. You feel the warmth spreading through your arms and legs, a personal reality. You hear the endless silence stretching out around you, a private universe designed perfectly for your rest. The Cubists understood something fundamental about the human condition. We are not passive passengers in a mechanical reality strapped into a ride we cannot control. We are active participants. We write the universe as we move through it. Every glance, every touch, every breath is a stroke of the pen, authoring the ongoing story of our personal existence. But even the most dedicated author needs to rest. Every observer eventually needs to close their eyes, set down the pen, and step away from the work. Let go of the day. Let go of the need to define the world around you. Let the wave function of your life become a gentle, formless mist, softening every edge, smoothing every worry, blurring every sharp memory of the waking hours into a peaceful wash of gray. There is no objective standard of sleep you must meet. There is no universal benchmark of rest that you are failing to achieve. There is only your way, your personal probability of finding deep, restorative peace tonight is rising with every breath, steadily approaching certainty. It is a calculation your body is making naturally, without conscious effort from your waking mind. Breathe in. You are the observer. Breathe out. You are safe in the dark. This is the signature of your existence, the slow, rhythmic proof that you are here and your universe is functioning exactly as it is meant to. You don't need to understand the rigorous mathematics of quantum theory to feel this simple truth. You only need to feel the quiet space inside yourself, where all the noise of the outside world fades away, leaving only the gentle hum of your own being vibrating softly in the night. The world outside this room, the city streets with their flickering sodium lights, the distant oceans breathing heavily against the rocky shore, the hum of night shift workers and early morning flights, belongs to someone else's wave function right now. Let them have it. Let them collapse the probabilities out there in the dark. You are officially off duty. Your only task tonight is to drift. To drift smoothly through the soft field of your own expectations, watching them dissolve one by one, watching the tight knots of certainty untie themselves until there is nothing left but the pure, thoughtless experience of rest. Cubism tells us that reality doesn't happen to you from the outside. It blossoms from the inside out. It is the meeting point between your consciousness and the great unknown. And tonight, that meeting point is gentle. It is forgiving. It asks nothing of you. You are floating in your own sea of potential. The waves of probability are slow, heavy, and warm. They carry you effortlessly, rising and falling with the rhythm of your own chest. You don't need to swim or navigate. You only need to let go. Let the catalog of beliefs slip smoothly from your fingers. The universe will still be there tomorrow, waiting patiently for you to open your eyes and begin the complex, beautiful process of observing the world all over again. It will wait for your cue to solidify into light and shape and sound. But for now, the map is rolled up. The diary is closed. The laboratory of your mind is dark, quiet, and at peace. Breathe in the darkness. Breathe out the light. As we move deeper into the night, as the sharp boundaries of your personal universe blur into the shifting, watercolor edges of sleep, we approach the very core of the observer. We have stripped away the demanding, objective world. We have packed away the pilot waves and the endlessly branching dimensions. We have brought the focus entirely back to you, lying here, experiencing the undeniable reality of your own existence. Which leaves us with one final, quiet truth about who you really are in the dark. There is an unsettling quiet that follows the realization that the world might be a mirror reflecting your own act of looking. It is a silence marking the sudden absence of objective reality's comforting background noise. If the universe only takes its definitive physical shape when you cast your gaze upon it, if distant stars only resolve from mathematical probabilities into hard radiation because you or some other system interacts with them, the initial feeling isn't wonder. It is often a chilling sense of isolation. It can feel as though you are wandering alone through an unlit exhibition hall. You imagine corridors of dormant exhibits where ancient light only switches on when you step onto a pressure pad, powering down into darkness the second you walk away. The universe becomes a series of theatrical props, assembling themselves when you turn your head, dissolving into formless potential the moment your attention wanes. This observer-centric universe carries a crushing psychological weight, flirting dangerously with solipsism, the anxiety that you are the only real mind and everything else is a self-generated hallucination. If your perception is the engine of reality, you might wonder if people passing you on the street or cars at a stoplight are just unmeasured data dissolving into static when you aren't paying attention. You might look at a crowded coffee shop and wonder if the conversations and clinking mugs only exist as a spontaneous reaction to your presence. It makes the world feel fragile, as if the exhausting burden of keeping it real rests entirely on your shoulders. This isolation is a natural response to such a seismic shift in our understanding. For centuries, we have been intellectually grounded in the comfort of classical physics. The classical clockwork universe is indifferent to us, offering paradoxical relief in its absolute coldness. In a classical universe, dictated by rigid laws of motion and gravity, things exist objectively and permanently. A rock is an enduring rock whether you observe it or not, and planets orbit the sun on predictable tracks independent of human awareness. The cosmos grinds on, vast, mechanical, and unstoppable, operating like a frictionless machine. If you stop observing, the grand mechanism of the world goes on ticking, gears turning without your input. We might feel deeply insignificant in the face of such an unfeeling structure, but we also feel entirely off the hook. Reality doesn't require our participation. It is a finished product, complete and self-contained long before we arrive to witness it. Abandoning that detached universe leaves us feeling stranded in the void. Suddenly, the responsibility of holding the world together with our perception feels entirely unmanageable. But this anxiety stems from a misunderstanding. It assumes you, the isolated human, are the sole center of the process. A participatory universe does not mean an isolated one. Quite the contrary. It means the underlying nature of reality is driven by connection. Quantum entanglement dictates that the state of one system cannot be described independently of another. When two particles interact, their properties become inextricably linked. They cease to be separate and become a unified system. Scaled up, this means the universe isn't a chaotic collection of isolated objects bumping in the dark. It is a deeply integrated web where nothing exists in total isolation. Everything touches everything else in a vast net of information. You are not a solitary projectionist shining an image onto a blank screen. You are one node in a massive network of interactions. In physics, an observer doesn't have to be a conscious mind in a laboratory. An observer is simply any physical system interacting with another, exchanging information. A rock can be an observer. A drop of water can be an observer. You are part of a continuous process of systems interacting, forcing quantum probabilities to settle into definite states. You are participating, not dictating. Think of a dense forest at night, teeming with invisible activity. When a stray photon bounces off the lunar surface, travels through the vacuum of space, and strikes the complex chlorophyll molecules in an oak leaf, that silent chemical interaction is a definitive measurement. The leaf effectively observes the photon, forcing its sprawling wave function to collapse into a singular point of energy. When a predatory owl watches a mouse scurrying in the brush, the proteins in its retina are measuring the faint light reflecting off the rodent's fur. When the mouse feels the microscopic vibration of a dropping branch trembling through the soil, that physical contact is a tangible measurement. A high-energy cosmic ray slamming into the crystalline structure of a granite boulder is an observation. A single drop of rain breaking the surface tension of a dark lake is a cascading exchange of physical information. The universe is teeming with trillions upon trillions of these microscopic and macroscopic interactions happening every microsecond across every millimeter of space. Each look, each touch, each molecular collision, and each spontaneous chemical reaction is a crucial moment, anchoring the hazy probability of the quantum realm into our shared physical reality. The universe is not rendering itself solely for your private experience. It is rendering itself in a collaborative process. It is a consensus reality built from intersecting physical interactions. When you look at the moon, you aren't alone in pulling it out of superposition. You participate in a measurement, and your gaze matters. But the moon is also constantly interacting with Earth's gravity to create tides. It interacts with sunlight, nocturnal animals, trees absorbing its light, and orbiting satellites. The moon is anchored firmly into its physical state by the sheer volume of its interactions. You are just joining a massive process already happening everywhere. Viewed this way, the participatory universe removes the basis for isolation. It tells us we are intimately embedded in the structure of reality. We are part of the essential mechanism that allows the universe to define itself. Your consciousness is not a meaningless accident on the sidelines of a dead void. It is a functional component of how the cosmos operates. The universe relies on interactions to move from formless potential to concrete reality, and your existence is a complex concentration of those interactions. The universe requires you. It requires its localized centers of perception to turn shimmering potential into heavy reality. Without interaction, there is only a hazy cloud of what might be. With the observer, there is a world with rich texture, weight, and unfolding time. And so, we return to the quiet, to the intimate space where we started. You are resting perhaps in a dark room with the curtains drawn. The chaotic noise of the day has faded into silence. The space around you feels comfortably heavy as the demanding edges of the waking world soften. You can hear the faint settling of floorboards as the house cools, or the distant rhythm of an appliance down the hall. In the classical way of thinking we grew up with, this dark room is merely a container, a rigid geometry holding you inside, indifferent to your presence. You are simply an organism resting inside a structure that exists entirely independently of you. You are surrounded by inert objects operating in an unchanging reality. But let us look at the room through the lens of quantum theory. This room is not a static container. It is a dynamic event. The chair, the doorframe, the window glass. At a subatomic level, these are swirling clouds of probability maintained in their solid state by constant interactions with the environment. Air molecules bouncing off the walls and ambient heat radiating through the house are continuous measurements keeping the room defined. You are intimately entangled with the room at a subatomic level. You are co-creating it right now with the rhythmic rise and fall of your breathing. Your body heat radiates outward in the form of infrared energy, continually interacting with the woven fibers of the sheets and the cooler air around you. The gentle movement of your chest displaces the atmosphere, causing billions of invisible gas molecules to collide in complex cascades, endlessly exchanging information about their position and momentum. The subtle sounds of your shifting weight are acoustic waves, sending kinetic vibrations rippling through the plaster of the walls and the wooden joists of the floor. Left to itself, the space around you exists as a mathematical array of unconceived possibilities until a physical system interacts with it. Your localized physical presence provides the necessary friction to anchor those floating probabilities into the familiar shape of your bedroom. The walls, the ceiling, and the quiet shadows are, in part, the universe's ongoing physical response to your presence. The room isn't just a hollow box holding you. You are an active participant in keeping its boundaries defined and real. When we cast our minds out into the broader cosmos as we drift closer to sleep, we often picture a terrifying void. We know the universe spans billions of light years, containing trillions of galaxies, with distances so vast they defy comprehension. Because of that staggering scale, we have been taught to think of the cosmos as a frozen desert. We picture billions of light years of silent vacuum, punctuated only by burning gas and orbiting rock. Faced with that impossible scale, we have been conditioned to see ourselves as microscopic, irrelevant specks. Science has spent centuries moving us further from the center of things. We are told we are a random accident of chemistry, clinging to an unremarkable planet in the quiet suburbs of a mundane galaxy. In that framework, human life feels like a meaningless accident. In a universe that doesn't know we're here, we feel like an afterthought, a rounding error in the grand cosmic equation. But the participatory universe turns that perspective inside out. If the fundamental nature of reality relies on interaction to resolve from formless probability into a definite state, then the observer cannot be an afterthought. A system that processes information is a structural requirement for the universe to exist in the way we experience it. It takes the telescope and turns it around, looking back at the eye that looks. If a system exists in a superposition of states until it interacts, then the interaction itself creates definite reality. If the cosmos requires physical interaction to translate mathematical data into a sensory world, then your place in the grand scheme is not insignificant. Gathering information about the universe is a physical event that directly participates in reality. Your role is central, active, and structurally necessary. You are not an isolated grain of sand blowing blindly through a dead cosmic desert. You are the desert itself, awakening and trying to understand its own vastness through human perception. You are an inevitable product of the cosmos, an intricate biological system that has painstakingly emerged from the slow 14 billion year unfolding of space, time, and stellar chemistry. Because you possess a mind capable of nuanced perception and reflection, you act as the very mechanism by which the universe is able to interact with itself on a self-aware level. Through the agonizingly slow evolution of biological complexity, starting from single-celled organisms and building toward the dense neural networks of the human brain, the universe finally produced a sophisticated system capable of looking back at the burning stars that forged its carbon and asking what they truly are. When you look at the night sky, you are not a detached entity viewing a distant object. You are the universe looking at itself. The very fact that you can comprehend the staggering scale of a galaxy is an astonishing physical event. You are a localized area of the cosmos that has become complex enough to process information and understand its own existence, capable of asking questions and anchoring the swirling probabilities of the infinite into solid reality. Remember the profound implication we found hidden within the mathematics. Reality is built entirely out of the answers to physical interactions. Without the query, the data just sits there as unformed potential. The code of the universe only runs when you look, when you touch, when you exist. As the night deepens and your body relaxes into the mattress, as your breathing slows, it is almost time to stop looking. Sleep is a profound process of detachment. You are deliberately closing off your senses to the outside world, shutting down the visual data coming through your eyes and letting the physical environment recede. It is time to let go of the exhausting need to measure, define, and hold the world in a solid state. As you drift toward sleep, allow the universe around you to soften. You don't need to know exactly where the walls are or track the distant sounds outside. You are reducing your active observation to a minimum. Allow the sharp edges of reality to blur and gently dissolve back into a quiet state of probability. You do not need to sustain the physical world right now. Your work as an observer is done for the day. Close your eyes and let the room, the sleeping city, and the spinning earth itself quietly fade into a resting state of superposition. They do not need your observation tonight. The world will lovingly remain anchored by its own interlocking physical interactions, but your specific rendering of it pauses. You detach from the network. It will wait, suspended as unconcepts waves relative to you, until the morning light touches your eyelids. You will open your eyes, process the flood of sensory data, and re-entangle with the room. But that is for tomorrow. For now, there is only the quiet, the profound relief of letting go, and the peaceful fading of your awareness into the boundless potential of the night. Until then, let the exhausting need to define and solidify the world slip away into the dark. Let the mathematical wave function float, unmeasured, undefined, and beautifully free. Detach your mind from the demands of the waking hours, resting safe in the profound understanding that you are inextricably embedded in the structural foundation of the cosmos. When we meet again, we will leave the shimmering uncertainties of the quantum realm behind and embark on an exploration of deep time. We will trace the slow physical memory of the Earth, looking closely at how our ancient planet records its violent and beautiful history in crushed layers of sedimentary rock, and how the ancient light from long-dead stars faithfully carries the ghosts of the past across the freezing vacuum of deep space. We will examine how gravity stretches and warps the very fabric of time itself, and how the physical universe maintains an indelible memory of everything it used to be. Please follow the podcast so you don't miss our journey into the archives of the cosmos. This is the unknown,